So one of the most common difficulties we see when helping companies is how non-standard part modeling techniques lead to major inefficiencies. I mean, with everyone modeling their own way with differing levels of skill, we find that parts are too complicated to understand, to predict, or to reuse, and so the easiest solution is just to redo the model entirely because it's harder to change it without errors. Assembly mates fail when part geometry changes, because when adding these parts, you are forced to mate to the geometry faces, which makes your model delicate and prone to mate errors. Drawings don't import model dimensions neatly, which usually means the user spends this time redoing all part dimensions as drawing dimensions. So now I will show you the basic concepts that we use to perform our part modeling to overcome these frustrations. The first thing to do is to put down your first sketch that captures the most design intent. In this case, I've taken it from the front plane. Now there are four basic concepts when laying out these sketches. The first one is, again, you have to capture the most obvious design intent. In this case, the origin is going to be right where the lens is. Secondly, you want to draw all features and holes even if they're hidden in this particular face. So in this case, I've captured a hole right here and another tapped hole right here. Okay. Third thing is to make sure that you give your dimensions meaningful names whenever you can so that anyone can easily understand what you've been doing. So in this case, this is called the hex hole and this is called the lens plate. Okay, so once you've done your first sketch, then the following ones are done in order of priority. So in this case, we've chosen the right view, and you'll see that this sketch has been almost fully dimensioned. Now what you do is you want to avoid doing double dimensioning. So because the height has already been established in the front view, all we're simply going to do here is make that coincident to the front view, and now the front view will drive that height. Again, you can see here that we've given some meaningful names to some important things like the hex hole and the side cutout. Okay, and lastly, we'll do the top layout, and in this case, when I click on it, you can see that we're only capturing a few remaining features. In this case, the threaded hole depth and this hex hole. But you notice that there are no X and Y dimensions for this. There's merely the diameter. But if you trace these lines back, you can see how they are connected to the front view. All right, so let's get started with the features. So when it comes to priorities, what you always want to do when you're making a feature is to always take advantage of symmetry. So because this part, a lot of it is symmetrical, we will simply model half of it for convenience. We want to avoid typing in distances into the dialog boxes for extrudes. So what you prefer to do is always go up to your sketch vertexes or sketch elements or any other type of geometry in the background. All right, so now let's just make a mirror of that and we can see what it looks like when it's going to be complete. Okay, another thing we can do here is we can put in our hole wizards. And again, you always want to use hole wizards as opposed to simple extruded holes because of all the advantages that you can gain from that in your drawings and putting fasteners in. So let's just simply make a 1-inch hole that goes all the way through. And just snap it to that point. Okay, and let's also put in our tapped holes. Now these are just going to be up to vertex because we've already given a sketch element here that shows the depth of our hole. All right, so let's just put that on here. And here's a vertex we're looking for. Okay, so we've got our one hole, but we want to make the whole pattern. So because we've already established the X and the Y for this, we'll just simply do a mirror for that. So patience while I just get this sorted out. There, so this whole pattern can just be driven by this one point on our front sketch. All right, in the interests of preserving our effort and minimizing our work, let's do the remaining features before the mirror. So let's make that bevel. All right, and before we roll forward, let's finish up with the chamfer that we want on here. All right, so when we roll forward, we've got everything we need. Now this revolved cut is in the center of the model when it actually wants to be out here on this face. And there's not a way for us to transpose that feature off to a face. So what we'll simply do here is instead of making a new sketch, we're just going to insert a derived sketch. Okay, and to make sure that it's always properly in line, then we'll just make it all coincident to the underlying sketch. Okay, and one last feature is this hex hole through the body. So you notice I don't have to make another sketch just to do this. I'm simply going to reuse the original sketch. Okay, so there's our model complete. So now we need to think about what if you came back to use your model again several months later, would you easily remember how you did it? Or if you let someone else use your model and they had to repurpose it and edit it, could they easily and quickly do it, or would they give up and remake it from scratch? To be a truly professional modeler, you'd want anybody to come in here and reuse your model and take hardly any time to figure out how you did it. So for example, this hex hole, I don't want it coming into my chamfer, nor do I want it coming into my shoulder here. So how do I find out how to edit that quickly? Okay, so normally I would click on here And I can see there are no X and Y dimensions, but if I look, I can trace them back to the front sketch. So I just go to my front layout sketch, and there it says right there, hex hole. So now it should be simply a matter of moving it until it's right. There we go. I see a problem here where this may not be quite so manufacturable, but how do I change it? So normally I would click on here and I don't see any dimensions at all. If I go to my feature manager tree and I click on that sketch, it leads me right back to the source, which is the right layout sketch. I click on the right layout sketch, and sure enough, I can see that that's where the dimensions are. So I'll just drag this out here, and that's more like how I need it to be. Okay, if there's anything else I want to change, I can just choose the proper one and see how this model reacts when I change things. So there's that. And how about down here? This width. Does this shoulder ride in something else? What happens when I change the width of this whole part? Does this shoulder move wider with it, or does it stay? So let's just see what happens. If I change the width, okay, so I see that the shoulder stays the same, but also that it also gets higher by the same amount. So now I know the design intent for this part. Right, so we should be able to now see how this goes into a drawing. I don't want that annotation. Alright, so all we should have to be able to do here is insert model items, import it into all three views, and our drawing is basically dimensioned. If I want to tidy that up, there is the auto arrange dimension command, and there I am, basically done. Now I see when I look at it that my revolved feature's on the far side, and I need to be doing my three view on the other side. So normally you'd have to redo a lot of your views and dimensions, but here let's see what happens. In fact, let's even delete all dimensions just to make this more dramatic. So let's redo this three view the way that I need it to be done. Okay, let's insert the model items again. And we practically have our model dimensioned already. I see there's a few things here I'd like to change. For instance, I'd like to get the XY dimensions for this hex hole. Okay, now I'm looking for the other one, but it's kind of hard to see in here. So by looking at the dimension names, I can easily see which is the one I'm looking for. Oh, this one didn't get dragged in, so let's try that again. No use struggling with one single dimension. It's just super easy to just auto arrange the whole thing. See how I left the names on? Should have turned those off. So let's just turn those off. And again, auto arrange all those dimensions. So this is a fairly simple example, but let's show you an even more dramatic example. of a much more complicated part. Let's insert the model items. And here you can see how it's all ready to go. When it comes time to insert your parts into your assemblies, you want to avoid as much as possible using geometry faces for mating. Your assembly mates will tend to fail whenever part models are updated. Always try to use reference geometry for mates, such as these planes and axes. If your parts have captured the design intent, then you will have these reference geometry features available. Here we'll use the planes and axes with coincident mates. Well, if you've watched this video all the way to the end, I hope you got the value that you were expecting from it. If you agree with this method, then I encourage you to adopt it because we and our customers save so much time working with SOLIDWORKS parts, assemblies, and drawings. All right, goodbye until next time.